Garden supply companies want you buying $200 rolls of plastic landscape fabric that eventually breaks down into microplastic pollution. But European peasants figured out 1,000 years ago that you can permanently smother weeds using thick layers of organic mulch that decompose into soil instead of trash. They just turned weed-infested land into productive beds for $6 using cardboard boxes anyone would recycle. This is the lawn care industry's decomposition nightmare, a gardener who refuses to till, weed, or buy their barriers. Watch them perform layering alchemy that turns waste into weed-free soil. Industrial plastics force you into a cycle of constant repurchase as they degrade and poison the earth. Deep mulch operates in reverse. It is a biological investment that compounds year after year, converting free organic matter into permanent topsoil. This medieval practice relies on a strict empirical mechanism, complete photo control. As this schematic illustrates, plants require light for photosynthesis. Block that light completely for at least 8 weeks, and you physically starve the existing vegetation. The result is total plant mortality without a single drop of herbicide. This also neutralizes the dormant weed seeds buried below the surface. By piling organic matter 8 inches high, you create an impossible physical distance. Seeds may germinate, but they will exhaust their stored energy and wither long before they reach the surface to find light. Standard mechanical tilling achieves the exact opposite. A plow violently churns the earth, exposing thousands of deeply buried seeds to the active photic zone, ensuring a continuous, guaranteed crop of new weeds. By replacing the physical plow with top-down decomposition, the native soil structure remains intact. The existing biological networks, earthworms, bacteria, and fungi, are left undisturbed to process the organic matter from the surface downward. Weed management, therefore, is not an issue of mechanical disturbance. It is solved entirely by permanently altering the surface light environment. To achieve this complete light exclusion, the initial layer requires plain, uncoated corrugated cardboard. Using glossy or plastic-coated cardboard will completely fail. The barrier must block all sunlight while remaining completely biodegradable, allowing soil microbes to eventually consume it. Above the cardboard sits the primary mass of the system, ramial wood chips. These are young branch materials, highly nutrient-dense, and readily available for free. Municipal arborists and local tree service companies will gladly dump truckloads right on your driveway to avoid paying landfill fees. These specific chips provide the precise carbon-to-nitrogen ratio necessary to fuel sustained, slow-release humification. This split-screen comparison directly contradicts a common agricultural myth that wood chips tie up soil nitrogen. High-carbon materials only deplete nitrogen when actively rototilled into the soil bed. When placed on the surface as a static mulch, soil nitrogen remains entirely stable. However, there is one strict biological exclusion. Walnut chips contain juglone, a potent allotropic compound that chemically inhibits the growth of competing plants and must be entirely avoided. When selected correctly, sourcing this free municipal waste transforms what would otherwise be rotting landfill mass into a pure biological catalyst for your soil. Installation begins with careful site preparation. You mow existing vegetation down to the ground, but you do not remove it. That dead plant matter stays exactly where it falls, acting as the primary decomposition starter layer. Next comes the cardboard. Every single seam between individual pieces must overlap by a strict minimum of 6 inches. This layer must be thoroughly saturated with water immediately upon placement. The moisture jump-starts the decomposition process and physically anchors the cardboard to the ground, preventing wind displacement. Then, the high-carbon mulch is piled continuously to an exact depth of 8 to 12 inches directly over the wet cardboard. Cheating this depth parameter will result in failure. Aggressive weeds like bindweed will exploit gaps under 6 inches, navigating through the mulch to reach sunlight. The initial extreme depth accounts for the physics of rapid, early-stage decomposition. The mulch pile will settle and naturally lose 30 to 40% of its volume within the first few months. The complete seam overlap and the strict depth metric are non-negotiable engineering tolerances. Compromise on either and you break the photo control seal. You do not have to wait for full decomposition to begin using these beds. Planting can happen immediately through spatial separation. To plant, simply pull back the heavy mulch to expose the cardboard. Slice a clean X directly through the barrier, insert the transplant, and push the mulch back around the stem. This action forces the root mass to completely bypass the high-carbon wood chips and interface directly with the nutrient-rich native soil below. Once planted, the thick surface mulch does not act as a growth medium for the plant. It serves purely as physical armor against any competing weeds. Simultaneously, the system alters the underlying hydrology, as seen in this diagram. That 8-inch organic layer functions as a massive vapor barrier. Instead of moisture evaporating into the atmosphere, the mulch traps it, condenses it, and cycles it back down into the root zone. This continuous vapor trapping mechanism causes overall agricultural irrigation requirements to drop by 50 to 70%. The physical installation of the barrier shifts the entire plot. What was an active, resource-heavy grid becomes a passive, self-hydrating environment. Between year 2 and year 5, the biological endgame reveals itself. The cellulose cardboard layer undergoes complete microbial degradation, vanishing entirely from the soil profile. Saprophytic fungi and earthworms aggressively colonize the environment, breaking down the lower layers of the wood chips from the bottom up. This creates a critical structural result, a humus interface. This is a thick biological fusion zone where decomposing organic matter seamlessly converts into rich, native mineral soil. Because this process is continuous, top-down humification passively raises the soil line by more than 6 inches, establishing a permanently raised bed without a single shovel load of imported dirt. The system essentially reverse engineers the slow, centuries-long process of a forest floor building its own soil, condensing that biology into a hyper-productive 5-year cycle. This creates an operational advantage called the sovereignty multiplier. Once that humus interface is established, human physical input drops to near zero. The only ongoing maintenance required is a simple annual top dressing of 2 to 4 inches of fresh wood chips. This maintains the essential depth required for strict photo control. By implementing this design, the gardener eliminates weed pressure, removes the physical need for a plow, and actively builds deep topsoil entirely from free municipal waste. The garden supply cartels want you buying $200 plastic barriers every few years, but medieval peasants proved 1,000 years ago that permanent weed control comes from deep organic layers. Unearth the History is here to bring you the techniques they can't monopolize. Start your mulch rebellion today, pile the layers, and subscribe to keep the resistance growing.